Hassan's Maths channel. I'm now answering question number 21 from the specimen paper B from the 0580 Cambridge IGCSE paper 2 non-calculator paper. And this question here is about this triangle, or these two triangles that are stuck together, two right angle triangles ABC and ACD, and we have to find the value of cosine of the angle ADC. Okay, so what I'm going to do is I've just taken a little screenshot of this and I put it down here so that we can have to keep scrolling up and down when showing our steps. So I've got a smaller version of that diagram down here. So basically what we have to do is we have to find the value of the cosine of the angle ADC. This is the angle that they are referring to, ADC. Okay, this is the angle they're referring to. Let's call that angle theta. We want to find the angle theta degrees. Okay, now, if we look at the triangle ADC, we want to find this angle. We know one of the sides in this right angle triangle. We know the adjacent side. Okay, so that's the adjacent side to the angle that we have to find. So we know the adjacent side. Okay, now we don't know any other side. We need to have one other side on this right angle triangle in order for us to find the cosine of angle ADC. In fact, not only that, we have the adjacent side, we need to have the hypotenuse. We need to know what the hypotenuse is, because we know the cosine of the angle, as we know from SOHCAHTOA, we're talking about right angle triangles. The cosine of an angle is adjacent over hypotenuse. So we have the adjacent, we need the hypotenuse. So how would we find this length of this side? Well, from this triangle, we cannot find it directly because we don't have enough information. But what we can do is we can look at the triangle ABC and we can think about the side AC, which is part of both triangles, is a common side to both triangles. If I can find the length of AC and then I know already DC, I can then find the length of AD and find what we're looking for, which is the value of the cosine of ADC. Notice that they're not asking us to find the angle ADC, they're asking us to find the value of the ratio of the cosine of the angle, which is basically this length over this length. Okay, so cosine ADC is basically going to be the cosine of angle ADC. Angle ADC is going to be basically CD over AD. CD over AD will give us what we're looking for. We have CD, we need to find AD. All right, so we can find AC in this triangle by using the fact that we have this angle here, and we have the opposite side. We have this in this triangle, this is the opposite side, and this is the hypotenuse in this triangle. Okay, maybe I should put it in a different color to make it clear. Okay, that this is a different triangle. Okay, so this is the opposite side. This is the opposite side, and this is the hypotenuse in this triangle here. Okay, so we can find this side here by using the fact that we have this angle on this side, so we can use the sine. Okay, so we can use the sine ratio. But remember, we have a non-calculator paper here. Okay, so here we can say that the sine of angle 30 degrees is equal to 6 over AC, which we're trying to find. Okay, which means AC is equal to 6 divided by sine of 30. Right, now, this is where it comes into play that we should know certain ratios of certain angles in the exact values. We should know them, we should memorize them. And one of those angles is the sine of 30 degrees. Okay, and we should understand that the sine of 30 degrees is equal to a half. So this is like 6 divided by a half, which is like 6 times 2 over 1, which is 12. So this here is 12 centimeters. Okay, now how did I know it was 12 centimeters? How did I know sine 30 is a half? Well, that's from our understanding of certain values that we should know from the sine, cosine, and tangent ratios, which is something that's important for us to know. Okay, and the angles that we should know, and I'll just make a little graph to show as follows. Okay, we should know the values of the sine, cosine, and tangent of 0 degrees. The sine of 0 is 0. Okay, and we should also know for 30 degrees, for 90 degrees, for 180 degrees, for 270 degrees, and for 360 degrees. We should know certain ratios. So let me just make this bigger. Okay, so we should know like this much. So we should know for 0, definitely for 90, for 180, and for 360, and also 270. We should know from the sine curve what those values are. We should also know for the sine of 30 degrees, and for the sine of 60 degrees, and for the cosine of them as well. Okay, now for some of these angles, we need to think about a equilateral triangle that's cut in half. Supposing we draw an equilateral triangle, and then we cut it into 2 equal halves. Just say this is an equilateral triangle. And when we cut it into 2 equal halves, okay, 2 equal halves, let me just make that neater. Okay, we're left with a right-angled triangle where this is, say the original lengths were 2 each. This would be 2 now, this would be 1. And this would be the square root of 3, because 2 squared minus 1 squared is going to be 4 minus 1, which is 3, so that's square root of 3 by Pythagoras. This angle would be 60 degrees, because it's the angle in an equilateral triangle. And this would be half of 60 degrees, would be 30 degrees. So we can see from here that the sine of 30 is 1 over 2. And the cosine of 30 is root 3 over 2. And the sine of 60 is root 3 over 2. And the cosine of 60 is 1 over, cosine of 60 is 1 over 2. So we got some certain exact values of sine, cosine, and tangent we can find from this triangle. And also we can find it from the isosceles triangle with sides 1 unit each. That gives us 45 degrees. Okay, so I have answered, or I have shown some of these kind of concepts in another video, which I will link at the end of this section. But basically what we should understand is if we have 30 degrees, 60 degrees, 90 degrees, 0 degrees, 180 degrees, 270 degrees, and 360 degrees, we should at least know these. Okay, for sine, cosine, and tangent. So I'm going to write down here some of the values of these for sine, cosine, and tangent of these angles. Okay, so we have the sine and cosine and tangent. So for sine of 0 is 0, tan of 0 is also 0, and cosine of 0 is 1. And one thing you'll notice is that the tangent of an angle is, well, we'll come back to later. The sine of 30 is a half. The cosine 30 is root 3 over 2. The sine of 60, I'll do the tans in the end. The sine of 60 is root 3 over 2. And the cosine of 60 is a half. And the sine of 90 is 1. And the cosine of 90 is 0, because the cosine curve goes like this. It's from 0, from 1, 90, 0, and 180 degrees, the sine of 180 degrees is 0 again. The cosine of 180 degrees is negative 1. It's going to be down here. The sine of 270 is minus 1. The cosine of 270 is 0. And the sine of 360 is 0. And the cosine of 360 is 1. Now, one thing you'll notice is that the tangent is always sine divided by cosine. So if I do a half divided by root 3 over 2, it's like a half times 2 over root 3. You're left with 1 over root 3. So if you ever forget the tangent ones, just divide the sine and the cosine, you get them. Root 3 over 2 divided by 1 over 2 is going to be root 3. Okay, root 3 over 2 divided by 1 over 2. Is root 3 over 2 times 2 over 1, gives you root 3. And the tangent of 90 is going to be undefined. Okay, because 1 divided by 0, you can't divide by 0. And we know that the tangent curve at 90 degrees, you have what's called an asymptote. Okay. And the tan of 180 is 0 over minus 1, which is 0. Okay. And the tan of 270 is also undefined because you're going to have minus 1 over 0. So the tan of 270, the tan curve will look like this. And there's an asymptote here. And then the tan of 360 is going to be back to 0 again. Tan curve looks something like this. Okay, so these values, we should know them. All right, these values, we should know them. Okay, and if you forget the tan, you can just use the sine values, divide them by the cosine values, and you get the tan values. Very important that we know these exact values. Okay, and in an exam that you can recall them without having to go through much bother. Okay, because you don't have too much time and you don't want to be fluffing around. So if you know them, good. If you have to derive them, that's still good, but you don't want it in the exam, lose too much time. So in this case, as we said, that's the reason why we can say sine 30 is equal to half. We know the exact value, which means this length is 12 centimeters. And now we can proceed. So I'm going to get rid of all of this stuff I've just written here. These things. Okay. Now we can proceed. Now we want to find this length. So I need adjacent over hypotenuse. I know this is 9. I know this is 12. I know it's a right angle triangle. And I know I can apply Pythagoras' theorem. Now, before you start actually going through the whole process of using Pythagoras' theorem with such big numbers, 9 squared plus 12 squared, and then, you might get confused with big numbers. Always check to see, is this a type of triangle that we can use, our understanding of the exact trig, Pythagoras triples, the Pythagorean triples for. So we have different types of triangles. You have a 3, 4, 5 triangle. You have a 5 and a 7 and a 12 triangle. Okay, that's 144 plus 25. 5, 7, 13. Is it 5, 7, 13? 5, 12, 13. So what am I talking about? I'm mixing up two others. 5, 12, 13. Because 5 squared plus 12 squared. That's 144 plus 25. That gives you 169, which is 13 squared. We also have the 7, 24, and 25 triangle. Okay, these are different types of triangles, and this is probably the most common that you'll see in IGCSE in this type of question. Always look out for this to make life easier. So I can see that 9 is like 3 times 3. And I can see that 12 is like 3 times 4. So this side must be 3 times 5 because it's like a 3, 4, 5 triangle. 3, 4, 5 triangle. Okay. And if we were to calculate it, you would also find the same thing. So AC is equal to, or the length of AC is equal to the square root of, okay, you'd have got 9 squared plus 12 squared, which would have given you 81 plus 144, which is going to be, that's 125. Okay, 81, in case you're not sure, you can just add them together. That's 5, that's 12, 225. Sorry, what am I talking about? 225. Okay, so that's the length of AC, the square root of that. And the square root of 225, we should know it's 15. But in case, that's a bit high, that number for you to think of, or the numbers might come up quite big and you're not sure because you don't have a calculator, then this is a nice technique you can use. Try to think of having a common factor. Try to take out a common factor from these numbers, which is the same in all cases. And what you're left with are numbers which are in this ratio 3, 4, 5, 5, 12, 13, 7, 24, 25. There are other Pythagorean triples, but I'm guessing this would probably be the most common one that you might see. Okay, so in this case, that makes life very much easier. So I know that this is 15 centimeters. So therefore, I can say the cosine of angle ADC, which we've called theta, is equal to the adjacent, which is 9, over the hypotenuse, which is 15. Okay, so we can simplify that, divide by 3 and 3, that's 3 over 5. 9 divided by 3 and 15 divided by 3. So we can say that is the value of the cosine of angle ADC. And that completes this question here. Now, this is a question about trigonometry, and it's a question about the exact values of trig ratios, which is something new in the syllabus, which we must know. So we must know what the sine of 30 degrees is without using a calculator. And secondly, mistake people make, find the value of cosine ADC. There are a lot of people will go on to try to find the angle ADC, which of course you won't be able to do in this paper because you don't have a calculator and you get confused. No, they're only asking you for the ratio of cosine of ADC, not for the value of it. But what we needed to know was the value of the sine of 30 degrees. Okay, and the table I drew earlier hopefully will be useful for you in answering such a question. Okay, so thank you for watching. Other questions from this particular paper can be found in the top right of the screen at the end of this video. There's a link there for that. There's a link also here for the topic of trigonometry from these new type of questions from 2025. And here I'm going to have a special playlist just for exact trig values. And I'll add this to that playlist as well. You can subscribe to my channel by clicking on the link on the top. Thank you for watching and see you soon.